Example number 3. At first glance, this doesn't seem to be the case of similar rational expressions because our denominators are different. But take note that the denominators are closely associated with each other, and we can actually easily convert this into similar rational expressions. We can do that by factoring out -1 from the denominator of the second rational expression. That is, by factoring -1 from this denominator, it would then result to -1 times -1 plus 2r. This can be rewritten as -1 times 2r minus 1. So the original expression can now be expressed as follows. Now take note that this factor of -1, we can instead place this into the numerator and end up with the following expression. Our manipulations have then resulted to having the same denominator of 2r minus 1 and 2r minus 1. So in effect, we are now dealing with similar rational expressions. By multiplying -1 to r squared and -1 to 1, we will then have 5r squared over 2r minus 1 plus -r squared minus 1 all over 2r minus 1. At this point, we are now going to operate with similar rational expressions. So with that, we then follow the usual steps on adding the numerators and copying the common denominator. That means we add the numerators of 5r squared plus -r squared or minus r squared plus -1 or minus 1 all over copy the common denominator of 2r minus 1. Combining the like terms of 5r squared and -r squared, we will then get 4r squared minus 1 all over 2r minus 1. Now, simplify this result by trying to factor out the things that can be factored out. I hope you realize that this numerator can be factored because this is the difference of two squares. We can then factor the numerator as 2r plus 1 times 2r minus 1 all over 2r minus 1. It's clear up to this point that we have a common factor between the numerator and the denominator, so we cancel out that common factor of 2r minus 1. And we end up with the final result of 2r plus 1. Now again, be mindful of your restriction. If you take a look at this expression, we have a denominator of 2r minus 1. That would only mean that r cannot be equal to positive 1/2. Because again, if r were equal to 1/2, it would result to a denominator of 0, and we would end up with an undefined expression. So the final answer is 2r plus 1, where r is not equal to positive 1/2. Example number 4. Take a look at your denominators. They are the same. So we are working here with similar rational expressions. Add the numerators. We get 5k plus 20. And then copy the common denominator, which is k squared plus 3k minus 4. We then simplify this rational expression by factoring the things that can be factored. The numerator, it can be factored by taking out the GCF, which is 5. This will then give us a cofactor of k plus 4 over your denominator is a type 1 trinomial. And the way we factor type 1 trinomials is to think of two numbers whose product is -4 and whose sum is +3. The two numbers that would satisfy such conditions would be the numbers 4 and -1. Since 4 times -1 is -4, and when you add 4 and -1, it would give you 3. Therefore, k squared plus 3k minus 4 can be factored as k plus 4 times k minus 1. Here, we would now see that there is a factor that's common to both the numerator and the denominator. So we cancel out k plus 4 and end up with 5 over k minus 1. Again, the final answer comes with the restriction on the variable that would make the denominator equal to 0. So if we take a look at this factor here, k cannot be equal to 1 because if k were equal to positive 1, this would make the denominator 0 and we end up with an undefined expression. If we also take a look at this factor here, this would also imply that k should not be equal to negative 4. Therefore, our restriction is that k should not be equal to negative 4 or positive 1. This then is going to be our final simplified form. Work on exercise 7.03 now. You will find this in Schoology.